Hi, everyone. Welcome back again. We're going to be going over the first part of the Intro Jupyter Notebook, which is variable and data types and data structures. So again, remember, if we want to run Jupyter Notebook, one easy way is to open up Anaconda Navigator and then click Jupyter Notebook from here. And by the way, I forgot to mention this in last video, but when you close it, you can shut down Jupyter Notebook and Jupyter Lab. That way, when you quit, or if we're already running this Jupyter Notebook in the browser, which, oops, we can also go to, I think, hit quit here, and that stops this Jupyter server. So you'll notice it's running on localhost, which is your own computer, and then it has this colon and then a number. So that's a port number. So it's just running on your own computer at a web address, and then that's where it is. So let's see here. So this Python crash course, so you're going to want to download that from the materials here. And then we'll go ahead and find that and open it. So click on that file. That'll open it up. So getting started with this, the way we run code in here, and you shouldn't have these little collapsible headings, I don't think, unless you installed some plugins, so don't worry about that for now. But you'll see, so the top of these, you'll see each one of these little chunks is a cell, and the top cells up here are what's called Markdown. So you can see from this little drop-down menu here, these cells are all labeled Markdown. And there's a couple of different options. There's code and some others. Basically, we just mainly use code and Markdown cells. So Markdown cells, if you double click in here, you can see it's got some formatting. It's very simple formatting. So if you look for, whoops, Markdown cheat sheet, that's what I always like to use. And it has all the kind of basic syntax for writing Markdown. So in your Jupyter Notebook, you can write notes and save those in Markdown. It's a nice way to notate it. And you can put in links. You can see how that's all formatted here. And then, so once you're in a cell, once you've double clicked in a cell, you can press Shift plus Enter, Shift and Enter at the same time. And that will run the cell and move on to the next one. Or you can press Control and Enter, and it runs the cell and stays on the same cell. And then you can also see from help and then keyboard shortcuts, you can see some other ways to run cells. So here's Shift Enter, Control Enter, Alt Enter. Those are some different ways to run cells. And getting into them to edit them, you can click them or double click them. You can also run these cells by clicking the Run button right here. And if you want to make a new cell, you can click the plus button here for inserting a new cell. You can click the cut button to cut the cell, or there are a bunch of different keyboard shortcuts for creating new cells, A and B, and then D 2 times to delete a cell. So I like to use all these hotkeys. They really make things much easier to move around and make new cells. And then let's see. So one other thing, so this, you'll notice in the keyboard shortcuts, it has this command mode, which it says press escape to enable. And then it also has edit mode, press enter to enable. So those are the two main modes when we're running this. So if we're on a cell, we can press enter. Now we're in edit, or what is it called? And yeah, edit mode. And then if we want to get into command mode, from edit mode, we press escape, and we can see our cursor disappears. Now we can use the arrow key to move around, and we can use our command mode commands. We can always use the Shift plus Enter or Control plus Enter commands, though, at any time, and they'll run the cells. So that's kind of basic using Jupyter Notebook. So this first part of Python we're going to look at here are looking at some data types. And there's a few key data types. So we've basically got numbers, we've got text, and then we've got a few other specific programming types of data types. So for numbers, we can either have an integer or a float. Integers are just whole numbers like 1, 2, 3, 4. They can be negative, positive, 0. So we can store an integer, the number 1, and we can store it in this variable named an integer. And then if we put that variable at the end of the cell, it'll print out the value. So we can either click in this cell or we can navigate to it with the arrows, press enter. If we want to change something, we can change it there. And then we can press shift plus enter. That runs the cell, or you can click the run cell button up here. Highly recommend getting into the habit of using keyboard shortcuts though, as it's much more efficient. So here's our integer data type. And we're also introducing variables here, so we can create these variables. Best practices is to use what's called camel case, so lowercasing with underscores separating these words and some sort of descriptive name. So we've got our variable and integer. So then if we want to check what type that is to make sure it is an integer, we can use this built-in function called type. So functions in Python, we use the function name and then we give it parentheses and give some arguments to those parentheses. In this case, we just need to give it our variable that we want to check the type of. Shift plus enter in there, and it prints out integer for our integer variable. So if we want to convert these variables to different types, we can use these different types that are shown here: integer, float, string, Boolean, bytes. We can do what's called casting, where we convert it to that other type. So if we want to convert this integer to a float, for example, we can use the float function here, and that just converts our integer to a float. Or if we want to convert it to text, we can use the string function. So that's called casting, just kind of a nice thing to know. So for numbers, we can also use floats, and these have decimal places. So here's 1.0. If we check the type of it, it is a float. Okay, so those are integers, floats. We can do math with programming. That's one of the things it's nice for. So there's all the normal operations like addition. So we can do 2 plus 2, 2 minus 2, and division and multiplication, just like you'd expect as well. The multiplication is the star symbol. So we've got those. And then we've also got these other kind of special characters here. We've got the modulus operator, which is the remainder from division. So 5 divided by 2, and then get the remainder. There's 1 left over. So 2 times 2 is 4. And then there's a remainder of 1 to add up to 5. So that's the modulus operator. We can also get integer division, where we divide a number by another number and get the number of, and then round that to an integer. If we just have a single slash for division, it does float division. But of course, we could use casting to change that to an integer. And it's another way of doing something similar to integer division there. And then as far as math, there's a numerical Python package called Numpy, and that has a bunch of math operators like the logarithm. So that can be useful for doing math. There's also the built-in math module, which comes installed with Python. This Numpy is a separate package. It was installed with Anaconda. Math has other things like square root and stuff like that. There's also a square root in Numpy as well. So a lot of these functions overlap. But those are kind of some different ways to do math with integers and floats. So those are some very important data types. Another very important data type are strings. So this is for storing text. And these go between quotation marks. So they can either be single or double quotes. You can even use actually triple quotes. And the triple quotes allow us to put our text on multiple lines. So those are the three different ways of constructing a string. But for now, the easiest way is just with a single pair of quotes around the string. And so then when we print that out, it just shows our string. Kind of related to that, to these strings, is something we mentioned, I think. No, I don't have it at the top here. Okay, I'll put it in here, but something else related to this are comments. So comments, we can write comments in our code with a pound sign, the number sign. So that's like a single line comments that can come after a single line of code, or it can be on its own line. And we can also use these multi-line strings to make a multi-line comment. Yeah, because this is actually a string, it will print out if it's the last thing in the Jupyter cell. All right, a couple other data types. Booleans are true or false. So you can see when we type true with a capital T, it turns bold green, telling us it's a special keyword. And so we can check that type. It's a Boolean type, Boolean data type. And if we print it out, it just shows true. And then the other one, other Boolean value is false. So we'll see how that gets used a little bit later. And then the last thing is sometimes you'll see these bytes data types. So they're prefixed, it's like a string, but it's prefixed with a B. And so when you load data, sometimes you'll see data as a byte type. I think converting these to a string, I think it's something like this. Yeah, so you have to decode it in order to convert it to a string, but don't have to worry about that too much right now. It's just in case you see it, something with a B in front of it or a bytes data type, then you'll at least kind of know what to start asking about, what sort of terms to start searching for. For example, if you get some data as a bytes object and you want to convert it to a string, you could do Python convert bytes to string, and that's going to take us right to Stack Overflow. And someone asked that, and right there is the solution, decode it. So as long as you kind of know the right language to search the internet for, you can usually get pretty far. So some practice for you if you want to try it. A couple practice tasks here. So the next part are data structures. So this kind of builds on those data types and variables we already saw. So we can store a bunch of these variables together in a list. And this list is kind of the main data structure in Python. So you'll see these, they have square brackets and then entries. Each individual item is separated by a comma. So if we just make a list here called a list, it stores those 4 values. And these lists, the way we get different elements out of the list is with indexing. And so the way that works is we use 3 different values, or we have the option to use 3 different values. So we can use a start value, stop value, and a step value, with these being the defaults, 0, -1, and 1. So let's just look at an example to make this a little easier to understand. So if we want to get the very first elements of this list, we use the index 0. So Python is 0 indexed. It's kind of like centuries. So the the 21st century is the 2000s, for example. So where like the first century is years 0 to 100 to 99. So in the same way, Python is 0 indexed. So the first element is index 0. It's a little bit different from R. In R, it's actually 1 indexed. So the first index is 1. So that gets us the first element. To get the second element, we do that, third element, and fourth element. Oops, sorry. Fourth element. And so then that'll be a common error. You might see index error, list index out of range if we're trying to get an element that's beyond the length of the list. So then if we want to get more than one thing at a time, we can do what's called slicing it. So we can go from first element up to the third element. So this includes our start, but does not include the stop. So this gets elements 1 and 2. So it goes from element 1 up to element 3. And then if we want to get things from the end, we can use negative numbers. So we can go from the everything from the minus third elements up to the last element, but not including it. And so that gets us 2 and 3 here. And then the last thing in the indexing is the step. So if we want to get every other element, we can leave the start and the stop as the default of 0 and -1, and then get every other element. But if we leave those things blank like that, then it actually just leaves them as is. So it leaves them as their defaults. And then this step is handy because we can reverse a list just by giving it -1 for the step. So leave the start and stop as the defaults and then give a -1 to the list. Oh, right. And it gets a little complicated. Yeah, it gets a little complex because it also reverses which one is the start and the stop there. So anyway, it's easy to reverse the list with that. And so then the last couple things here for lists, they have these things in Python have many built-in functions, so called methods. And here's a link to the Python documentation on it. So this shows all the different things we can do with lists here. And so a common one is to use append. So we can add another number to the end of the list with our list, a period, and then append, and then the number we want to add or element we want to add. And then that just adds it in place. So the more we do this, the longer our list gets. Also, these things are very flexible. They can hold anything. So we could add a string instead here. And or we could even hold another list. So we can make a list of lists. So this list holds 2 different lists. So we can also change these elements of our list. So the first element we can change from 1 to 10. So we just changed that first element from 1 to 10. And then we can add them together as well. So this is called concatenation. We just use this plus symbol and it just stacks up 2 lists. Oops, I think I forgot to run this cell. This just stacks up 2 lists next to each other. So that can be handy. And something that's kind of related to this append method and this concatenation is the extend method. So you can see it in that documentation link that we looked at. It's got extend in here. And so it's asking for an iterable, like a list. So what we want to do is try using that for practice to extend this variable another list on the end of the a list variable. So that's lists, very useful and widely used data structure in Python. The other two we're going to look at, or other three we'll look at, are tuples, sets, and then dictionaries. And then I guess we'll take a touch on NumPy arrays and pandas, data frames, and series as well. So tuples are very similar to lists. In fact, we can make them out of a list just by wrapping them in the word tuple with parentheses. And that makes a tuple. The difference with tuples from lists is that you cannot change the elements of lists. So go ahead and try changing one of those elements of the tuple, see what happens. You will get an error. So tuples, sets. So sets are a very handy tool. They're the mathematical definition, which means they're a collection of unique values. So if we take our list and convert it into a set, all those duplicate fours are just converted into a single four. We can make another set here with 2 3s, and then we can see how that becomes just a single 3. So it's just got the unique values. And you can also see how we're making these either by using a set with a list or curly brackets. Whereas with the list, we had the square brackets. And then with a tuple, if we want to make a tuple from scratch, we can do it with parentheses. That'll be a tuple. So a handy thing about sets is we can check if something is in them. We can also do this with the list actually, but it's a little bit faster in a set because it uses something called hashing. So that's just a nice tool that we have available. And with sets, we can join them together. So as a challenge here, try using this operator. It's this pipe symbol union operator, and try joining those two sets we made. So building on sets, we have dictionaries. So a dictionary holds pairs of keys and values. And we create it similarly to a set. We can either use the keyword dictionary, where we have, let's see, actually, I don't remember how that works exactly, creating a dictionary that way. I don't really use it that much, but we can create a dictionary with curly brackets like this, where we give it a key, colon, and then a value. And then we can have a comma and then just keep adding these key value pairs. The keys should be some sort of string or number, and then the values can be just about anything, including a list. And so then we print it out and it looks just like that when we created it. And then we can add more stuff to this dictionary with this square brackets notation. So our dictionary and then square brackets, the key, and then we add another key to it. And then much like sets or lists, we can check if a key is in the dictionary like that. We can also list out all the keys with this keys function. We can list out all the values with the values function. So that shows us all of those things. And then we can get a combination of both of them with the items. So that gives us a list of these pairs of keys and values. And that makes me think, actually, that's probably how we, let's see if this works. Anyway, I don't, yeah, so if we want to make it with this dictionary function instead, we can do it like that. So try adding another item to this dictionary with key 3 for the key, and then hooray for the value. So dictionaries are another super useful data structure in Python. They get used quite frequently. And so you'll see those a lot. So next up, we'll look at NumPy arrays and pandas data frames. So we already talked about NumPy in the math section a little bit. This is numeric Python package. Typically import it like this. We'll get to the imports a little bit later, but just know that we're importing this package NumPy, and then we're giving it the shortcut name NP. So this allows us to, one of the most useful things about it is we can make these arrays, NumPy arrays. They're very similar to a list, but they can have multiple dimensions. So we can give our multi-dimensional list that we looked at, where we have two lists inside of a list, to our NumPy array. And then let's just look at what the full array looks like. So we can see it's stacked things. It kind of looks almost like a matrix, but there is actually a separate matrix data type in NumPy. But with this, it's nice because with this multi-dimensional list, if we want to get, say, so I'll call this multi-list. And then if we want to get, say, this middle column here, where it's the 2 and the 5, there's no easy way to do that with the multi-list. We can get one of those at a time by, say, doing this. And then we can get the other one by doing that. But there's no way to get both of these at the same time easily. By comparison with an array, we can grab these columns. So we can grab the 2 and the 5 at the same time. Or we can grab the first column, or we can grab the first row in all columns. So this indexing rows, columns, and then we can have even more dimensions, but a lot of times we'll see this as two-dimensional. So that is NumPy arrays. So try getting the last row and all the columns of the NumPy array for practice. And then, so building on that, we've got pandas data frames and series. So this is a very common data handling package in Python. So this uses NumPy to hold the data on the back end. Again, just like NumPy, we import it with this nickname PD. And then this data frame is kind of the main data storage type in pandas. And one easy way to make a data frame is to give it a dictionary like this. So our keys are like the column titles, the rows are the values, or sorry, the key. Yep, the key is the column title, and then the value for the dictionary are going to be the values for that column. So when we do this, it prints out a nice table here. And we can see we've got these two columns, people and revenue. And then the values are the different rows. And then it also gives us an index for those things. So there's a lot we can do with these Panda data frames, and they end up being a major data type used in all sorts of data science. So we can get columns by indexing this data frame with square brackets and then giving it a column name. And that gets us a pandas series, which a pandas series is just a single one of these columns, whereas a data frame is kind of like a big Excel sheet. So for practice, try getting that revenue column. And we do touch on this pandas a lot more in the courses, especially in the MSDE 620 course, is all about using pandas and pandas data frames. So that's it for the data types and variable types. So to recap, we looked at these basic data types, numeric types, integers and floats, text are strings, and then Booleans and bytes. Then we looked at data structures. Lists are a big one. Tuples are kind of like lists, but you can't change their contents. And then sets are unique values, lists of unique values, essentially. And then dictionaries build on sets by using a unique set of keys with values. And then finally, NumPy arrays build on lists by allowing us to make them easily multi-dimensional and add a bunch of other functionality. And then the pandas data frames and series build on that even further by storing data in an Excel spreadsheet-like fashion using NumPy arrays on the back end. So that's all. Hope this was helpful. In the next video, we'll look at functions, objects, classes, and scoping. And then we got one more video with loops and conditionals, and then one more with packages, modules, and finishing up. See you in the next one.